Everyone, I'm Jaime. Today we have the pleasure to present to you our journey in the implementation of VOCODER. VOCODER's objective is to assist programmers affected by strain injuries by offering them the alternative of coding using their voice to reduce the amount of stress induced by repetitive actions. In particular, it's addressed to Python developers and English speakers. We decided to do that by implementing an extension for the well-known editor Visual Studio Code, offering support for a wide range of procedural commands and a few editing commands, as you will experience in the demo. We are 6 students, Serena, Alessandro and Francesco from Politecnico di Milano in Italy, and Hilal, Alberto and me, Jaime, from Malardalen in Sweden. We met each other at the Distributed Software Development course, a course in collaboration between our universities and the University of Zagreb. Here we have the opportunity of learning how to work in a distributed environment using an Agile framework, in particular Scrum.
In our architecture, you can identify 3 main components. The actual Visual Studio Code extension has UI, a Python backend, and last but not least, our with.ai voice recognition model. This structure was a deciding factor in the allocation of the responsibilities, and we allocated 2 people at each component. Let's see how it works. The user input a voice command through the extension. This is forwarded through the backend to with.ai that performs the voice recognition, returning an interpreted command to the backend. The backend parses the received command, returning either a code block to be written on the editor or an action to be performed.
Now, going a bit more into some implementation details. The front-end has been developed using a mix of JavaScript that implements the API, Python for the voice recording, and a touch of batch files and bash scripts that automatically set up the environment. In fact, VOCODER is available for both Windows and Mac, and we paid close attention to make it a self-contained product, which means that any Python user is able to run VOCODER without installing any other dependencies. Using Python for our backend was also an informed choice. Since VOCODER is addressed to Python developers, we designed the backend to run locally on the user's machine, using their own Python installation. In other words, we traded a couple of additional minutes during the first installation with the lowest possible response time for all the voice commands. In order to set up the backend environment, we made a wise use of the front-end scripts and Anaconda, or if not available, VM. So we created an isolated Python environment with all the modules needed. Overall, at the beginning of the project, the team had very little knowledge about speech-to-text tools, let alone non-commercial ones. Since the choice for a good voice recognition model was fundamental for the success of the project, we decided to ask our sponsor for some advice. In return, he suggested us a couple of services that we could use as a starting point, and among those, the best one was with.ai, Facebook's natural language processor, not only for its speech-to-text accuracy, but also because it allows you to train a model for identifying intents and structure within the text. Finally, the responses are JSON objects, which are quite convenient to handle.
Since the work was split into sub-teams, it allowed us to speed up the implementation, but made the integration a harder task. To tackle this issue, the team created integration documents to define the structure of all data to be exchanged. The 3 parts are very different and therefore need different types of testing. Front-end testing was done manually since it was confined to being the elements displayed to the user to interact with the system. The backend used unit tests that were automated and varied between pre-recorded voice commands and method calls, testing individual functions. With.ai was tested as a black box with voice commands that we know the expected output, and they were checked manually to make sure that the AI model was trained on inputs with its corresponding output. And now we will show the results of our work in a demo.
Hello everyone, I'm Francesco and welcome in this demonstration for VOCODER. As you can see, I have already installed the extension in my Visual Studio Code environment, then I opened an empty Python file, and then the extension activated, and there is this login channel, and these 2 buttons in top right corner, one for recording and the other for changing snake camel case for long identifiers. Then we have this markdown file that tells you the terms and conditions, the prerequisites, the usage, and the available commands that we will see during this demo, at least some of them. There are a lot actually. But let's start with the first command. It's quite easy. Create comment. Let's write some square roots. Okay, and you will see that it takes about 4 or 5 seconds to get the response back. Very well. Okay, let's continue. Create function square root with argument number. Okay, and I'm using the key binding to the recording button. This is Ctrl+C. Very well, and that is a placeholder that it marks the spot where the next command is going to be printed. Create if statement. Okay, there are several ways to write if statements, this is just one. Okay, now we have 2 placeholders. So, call function print with arguments 0. Okay. And I'm waiting for the acoustic sound to start talking and when the command has been recorded. Okay. Expression, number equals 0. Okay. And this is just one way to write the if statement. I just wanted to show you the expressions. Okay, now let's move on with our parameters. So, define first number equals number divided by 2. I hope I didn't mess up. Okay, very well. Next one. Define second number equals first number plus 1. Very well. And now, from my side, this is it. And now I will leave this demo to Alberto, that is Spanish, so you can tell that VOCODER works also with different accents.
Hi, my name is Alberto, and I'm going to continue with this demonstration. Create a while loop until first number is not equal to second number. Okay. Assign variable auxiliary equal to number divided by first number. Okay. Assign variable second number equal to first number. Assign variable first number equal to first number plus auxiliary. Okay. Assign variable first number equal to first number divided by 2. Okay. Call function print with parameter first number. Okay, and to finish, call function square root with parameter 3. See. Okay, perfect, and there it is. With this we would finish our square root algorithm, and finally I would like to show you our VOCODER published extension in the marketplace, where you can see all the details about the extension. And before you leave us, let's run the code, and let's see. And as you can see, it calculates the square root of number 3, which is 1.73. Thank you for your attention, and I hope you really enjoyed as much as we did programming the VOCODER application.
Okay, Sarah, you're live.
Okay, so at last I can actually see people and hear people. So I'm sorry I missed the beginning. So this is the exciting first group, VBP. Can you hear me? I hope so. So
Yes.
We're backstage here. Now we have Paul Robinson from Sony, who is going to ask the initial questions to this group. We have a very, very short time scale. Okay, I'm going to read the question out, and then Serena is going to allocate someone to answer it. So the presentation mentioned the choice to code the project backend in Python and depend on the user's installation, which seems very reasonable. Do you document a minimum Python version? In a corporate context, I don't always get a choice about versions of software to install. Okay.
We actually need Python 3, but I think Francesco is the most suitable person to explain it better.
Yeah, so basically we run our extension with Python 3.8, and as we mentioned in the video, you can either install your own Python environment using Anaconda, and the extension will create a new environment on its own to have an isolated environment. Or if you don't have Anaconda, we have the VM options that is built in Python 3 that will do basically the same thing. So the default version that we are running on is Python 3.8. But of course, we can change that. There's no much differences among versions.
Okay, Paul, are you happy with that answer? Is that actually answering your question? If not, could you elaborate your question a bit or ask another one?
Yeah, there's another one already.
Okay, there is another one. Okay, so are you happy? Okay, it's just coming. Are you happy with the performance of the voice recognition and translation into commands? It seems that it works well, but there is an obvious delay between speaking a command and seeing the effect.
Okay, we are happy with the performance because our commands are recognized quite well. For the latency, it's the best we could get because we use with AI and we have to go through the internet, and there was no better locally because we had to use a non-commercial tool for the voice recognition. So that was the best performing one.
Okay, we have. I'm going to ask the one from Paul before Oliver, if we have time. In researching WIT.AI, it appears that it requires a Facebook login. Is that a requirement for using VOCODER?
No, it is not. It is just for the development part. So you don't need Facebook.
Okay.
Yes. Sarah, 1 minute and a half left.
Okay, so I think Paul is very happy. Oliver wants to know, could you comment on mouse usage? The demo showed mouse clicks. Are they really required? Is keyboard only usage possible?
Yes, we implemented some key bindings. So you also have the shortcuts for both the recording part and also for discarding a currently running recording. So there is the possibility to use keyboard.
Okay, so we have just under the minute.
Yeah.
Any other questions from the panel?
There are questions on that we missed.
Yeah.
I'm so sorry.
Yeah, some of them.
There's Igor Vise who asks, did you test the IDE with blind developers to get their impression?
Well, I think that the extension is not addressed to blind developers, but only to people that has strain injuries and they have limited mobility with their hands. So yeah, they can click around your IDE, but writing code is the real problem here because it's a bit more stressful for your hands.
Okay, 10 seconds. Thanks to all the team, Sarah. There's another question you may want to address by chat. the video is starting soon. Thanks again.
Okay. Thank you very much.
Thank you. It's a pleasure to be here.